Everyone hear me all right? No? All right, louder? Yeah? Better? How about that? All right, cool. Hi, everyone. I'm Aanand. I work for Docker, and I'm currently on two teams at Docker. Two teams, sorry, microphone. First team is called DX. That stands for Deus Ex, which is a cyberpunk-themed video game that was released in the year 2000. It's said of Deus Ex that every time someone mentions it, someone reinstalls it. So to whoever that is, you're welcome. Play it on realistic mode. It's really the only way. No, DX stands for Developer Experience, which is the task of making Docker really cool for developers. And the other team I'm on is Orchestration, which I would describe as automating the construction and management of distributed systems. In our case, those systems are made of containers. They're also made of computers that run containers. So we've got two dimensions there. So that's what I'm doing now. Just previous to this, I was at a startup with my friend Ben. That one's Ben, that one's me. It was called Orchard, and we were building stuff on top of Docker, variously cool things. That's us on top of the Docker building in San Francisco. I'm going to talk to you about one of the things we built today, which is called Fig. Oh yeah, the other thing is we're part of Docker now. Sorry, I'm joining that up. Fig, anyway. Fig is the thing we built. Fig is the fruit of the ficus tree, and it's really cool because the fig shares a codependent, it's co-evolved, and it shares a mutually dependent pollination process with a particular species of wasp. Basically what happens is that you don't have to read that, it's all good. But a female wasp will lay their eggs inside a fig, and then will die. And then in some figs, the eggs will hatch and more wasps will be born. And in other figs, they won't, and those figs will eventually become like ripe and edible. So what this means is that every fig you eat has a dead wasp in it. You can't see it there because it's been broken down into like sugar or something, but it's definitely there. That's why the fig is the coolest fruit in the world. That has nothing to do with a piece of software called Fig, which we also wrote, although I did choose the name Fig because figs are really cool. You can find out about it at fig.sh. It's for managing, creating, replicating development environments using Docker. The clue's in the name, as you can see, development environments using Docker. It's pretty obvious when you think about it. But yeah, so how Fig works is it's all centered around fig.yaml, which is a little file in which you describe your app. Now, hang on. There we go. So, like, multi-part, service-oriented app, made out of Docker containers. Each one of these top-level keys here, I'm sorry, I'm standing over here. Each one of these top-level keys here, web, Redis, that's like one container in your app, or set of containers, but let's keep it simple and talk in terms of single containers for now. Each one of these keys is basically an instruction to Docker, and it maps like very closely to Docker commands. So like build dot means like build an image for this container by doing a Docker build on the current directory. And then command is just like override the default command when you run this container. Links means link this container to the Redis container. Ports obviously means expose port 5000 to 5000. And volumes means like mount the current directory into the container at /code as a volume. And that's really cool for a reason we will see later. But yeah, anyway, I'll leave you in suspense for now. So like, yeah, and then we've got Redis. Which is much simpler. It just says, get the official Redis image. All right. So I'm going to show you a demo. We've got this file, and we've got 3 more files to demonstrate, but don't worry, they're all very small. Here's a little web app. It's a Flask app written in Python, obviously. It connects to a Redis. You see how we're connecting to a host called Redis_1 here, which is going to work magically through Docker links, which Jerome touched on earlier. And all we do is we increment a counter, and we show a little hello world saying, I have been seen X times, where X is the number of times it's been seen, and we are incrementing that counter as we go. So that's really, really simple. We've got requirements.txt to install Flask and Redis, which is pretty standard pip install kind of thing. And we've got a Docker file. You've heard of those, I'm sure. We basically just start from an image that's got Python installed, add our code in, run pip install. That's it. Cool. All right. Let's see that in action. What happens when we type fig up? All right. Firstly, try and create a Redis image. Pull the Redis image. Downloading. Oh my God, it's so fast. All right. Now we're going to Docker build the current directory to make our web image. Pip install. Love it. All right. And there we go. We're running a Redis. We're running a web. We're aggregating their logs. We've got nice colored prefixes. And we should be running on localhost 5000. Let's see if that's actually true. Yes, all right. And we can reload, and yeah, we'll get the counter, and it'll increment. It's so cool. All right. So there we go. That's it. We just wrote fig.yaml, we typed fig up, and we've got an app that's running. Also, I did mention, we're mounting the code inside a volume, which is going to overwrite what's inside the image, which is cool because it means that while we're developing, we can go make a change. Something a bit more specific to today, save that file, and then we can go back to our browser and be like, oh yeah, it's updated, and look, we've still got the counter from before. We haven't lost our data, so that's cool. In fact, we can actually exit fig and type fig up again, which will recreate the containers, create entirely new ones basically. But we go back, still got our counter. We haven't lost our data because the Redis image is pre-configured to use a volume. It says that in the Docker file, and Docker will respect that because when we create a new container, we do volumes from. Long story short, your database won't just disappear, so that's cool. Another cool thing we can do is we can start containers in the background. So fig up-d. We'll just start the containers and then exit, and that's fine because Docker is actually keeping them up. That's not our job. Then we can fig ps, we can see that they're running, and we've got ports and that kind of thing. So that's cool. That's cool for when you don't actually need to look at their logs. You just need to start a thing and then go away and do something else. And finally, we've got a nice little convenience for running a one-off command, which is really cool if you want to do a database migration or something like that. So we're inside the container. And another thing is that we've got the links that are set up. So come on, Aanand. There we go. We can ping the Redis host and oh, there it is. Cool. All right. Most crucially, if I commit this all to Git, push it to GitHub, and give a URL to my friend, then they can just git clone it and fig up. And as long as they've got Docker and fig installed, they'll get exactly the same environment. So that is the whirlwind fig demo. In my entirely objective, unbiased opinion, I think it's really cool. And yeah, so just to go over the design principles as I see it. First up, it's declarative, which means that you don't tell it what to do. You just tell it what you want, which ideally means less hard thinking on your part and more for us. It also means that we keep it simple. We only ask you for as little information as we can possibly get away with. You really couldn't reduce that fig.yaml to much less. It's repeatable, as I touched on. Git clone fig up is guaranteed to work the same everywhere. And finally, it's small. It does very little on top of Docker. It really just speaks to the Docker API. And is just a kind of minimal amount of logic on top of that. So yeah, that's Fig. We've gotten a fair bit of love from the community for it, and that's cool. For a lot of people, it's been their introduction to Docker. So people who didn't even know what Docker was before have started using it because of Fig, because there's a whole bunch of people who don't actually whose job is not actually to deploy code to production, but it is to develop code and feel the pain of non-repeatable hacky development environments. So yeah, That's actually all the presentation that I got around to actually making slides for. So I'm now just going to ramble for a bit, or maybe take some questions. Tell you what, I'll take one question now before diving into some other topic. So does anyone have a question? Please direct the microphone your way. And
Hi. So Fig is currently only works on a single host, correct?
Yep.
Are there plans to make it multi-host enabled in some way?
Yes. So before I get to that, I'm going to clarify something for people who might not realize, but Fig primarily is designed around using it on your local Docker host, like with, mounting code and volumes and stuff. But you can actually use it against a remote Docker host, and there are actually people using it in production to orchestrate containers on a single remote Docker host. It basically works exactly the same, except that you don't mount volumes, and that you want to use fig up-d. And that actually works really well. I don't have a demo of that ready, but it's pretty trivial, to be honest. In fact, we've got a blog on the Docker. We've got a blog post on the Docker website about that. So that's a thing. But yes, it only really works right now against a single Docker host. Fig against multiple hosts is like my dream. I really want it to work, but I want it to work in a way that doesn't mean that Fig has to make a ton of decisions about where to put things, or that you don't have to make a ton of decisions about where to put things. There's a lot of stuff going on in the space right now of multi-host Docker stuff and clustering, and we've got Mesos, we've got Fleet, we've got Kubernetes, we've got all kinds of, we've got Flocker. Basically, I want Fig to sort of be the ideal way to orchestrate some stuff, no matter what you're using the next layer down. So yeah, this is something that we are talking about all the time, and that I really want to do, and that a lot of our plans for orchestration are hoping to enable, not just for Fig itself, but for any tool that might hope to do the job of being the last thing between you and your stack of containers. All right. Yeah. Anyone else?
So looking at the stuff you had in the demo, is there anywhere in Fig that you could configure credentials? So if I've got a development environment, I might want to have a database password, which is then into my web container and so on. Yep.
So one of the fig.yaml configuration keys that I didn't demonstrate is the environment key, which, much like Docker, Docker run -e, lets you specify foo equals bar to hard code an environment variable, or if you just say -e foo when you Docker run, what that will actually tell the Docker client to do is to grab that environment variable out of your current environment. And Fig does exactly the same thing. So if you type fig up, you have an environment variable called foo that's set in that shell environment where you're running it, or wherever. And you have, in your fig.yaml, you have environment, an entry in the environment key just called foo. It will pull that out of the current environment. So that means that you can keep sensitive stuff out of your fig.yaml as long as you arrange for it to be there in the environment where fig up-d is run. That's the current answer we have to it. Obviously, as Jerome went over, there are various different ways. He was talking in the context of service discovery, of course, but then you can use the same approach to distribute secrets at production time and that kind of thing. How much time have I got?
Probably one or two more questions.
All right. Let's do one more question, and then I've got one more thing to say at the end. So.
Hello? Here
Hey.
we go.
So the Docker file used for development, do you recommend using that for production as well? So the image you built?
Yeah, I do. At least in I think in 80% of cases, my feeling is that you can use the same Docker file in development as in production. The only the thing that's different, the primary thing that's different when I'm working with Fig between development and production is that in development mode, I also I add my code into the container image using the Docker file with an add instruction, but then I overwrite that by mounting the code as a volume, which means that it will live update as I make edits and stuff like that, which just makes the cycle a bit faster. Otherwise, you would have to Fig build and Fig up -d again every time you make a change. One thing we've talked about is having a watch option, which we've played around with before, which basically watches whatever file, watches your whole build directory, and then whenever there's a change, it will in the background rebuild it and then restart a container with the new image, which is cool. It's still not. It's optimized because Docker's really nice caching and stuff. Excuse me. It won't do a full build every time, but there's still a bit of a delay to upload the build context and that kind of thing.
Don't you end up with the problem mentioned in the first talk where your build dependencies end up in your layered images?
Yep, you do. As Jerome says, we're still talking about what to do about that, but yeah. I can't really speak to that because I haven't personally had that problem, but yes, there's a lot of discussion going on around how to do stuff in your build that doesn't fill your artifact with stuff you don't need.
Okay, cool. Thank you.
All right. So I think I've got time to just say one more thing and then I'm done. Is that right? All right. So we're hiring in London. Ben and I are shortly going to be setting up the Docker UK office. We're going to do it here in East London because that's where we live and we don't really like traveling very far. And yeah, if you want to work on Docker, especially if you want to work on stuff like this, but really if you want to work on anything at all Docker related, please come and talk to me. Or if you're watching this in the future. And you're not physically here in this room, go to the careers page on the Docker website and apply. If you are here physically in this room, then come and talk to me at any point. And yeah, cool. All right. Thanks everyone. That's me.